Okay, Algebra 2, this is the lesson for Section 8 on quadratic inequalities. So I'm going to show you how to graph inequalities that are quadratic functions. Okay, example 1 wants us to graph the inequality when y is greater than x squared minus 3x plus 2. So we're going to start out by graphing this parabola the same way we would if it was an equation, just ignoring the inequality. So what I want to do is I want us to go back over vertex form that we did in section 7. I'm going to start by looking at those first two terms, x squared minus 3x. We're going to keep the y as greater than symbol. We're just ignoring that for right now. And we always wanted to see if we could factor out a number from x squared and negative 3x. This time there isn't a number in front of x squared, so we're not factoring anything out. So I'm going to write x squared minus 3x in parentheses. I'm going to leave a space to close my parenthesis and then plus 2. We're going to complete the square so that we can get this in vertex form. So we're going to take the number in front of x, which is negative 3. We're going to divide by 2 and square that term. That's going to go in the blank above here. So negative 3 divided by 2, we're going to leave that as negative 3 over 2. And then when I square that, we square the top and square the bottom. This is going to be 9 over 4. And I know that's an ugly number because it's a fraction, but it's still 9 over 4. Now remember, whatever we added into the parenthesis, we had to do the opposite on the outside of the parenthesis. So I'm going to put minus 9 over 4 at the end of this equation. Okay, so I'm going to go back and we're going to write y is greater than. We're still ignoring that for right now. We're going to write what's in parentheses as a perfect square. So it's going to be your variable and the number before I squared it. So before I squared it, it was minus 3 over 2. So x minus 3 all squared, or x minus 3 over 2 all squared. Then at the end, we have the 2 minus 9/4. So what you can do on your calculator is do 2 minus 9/4 and then change that back to a fraction by hitting math, enter, enter. And you're going to get that this simplifies to minus 1/4. Okay, so again, the purpose of us doing this is so that we can know the vertex of this parabola. This is vertex form. So remember, the vertex is HK, so the number that I pull out of the parentheses, we're going to change the sign, so that's 3/2. And then the number outside of the parenthesis, we're just going to keep that sign, which is negative 1/4. So our vertex for this parabola is at 3 over 2, comma, negative 1/4. I'll come back to that in just a second. Because in front of the parenthesis there's an understood positive 1, I know that this parabola opens up. Okay, another important feature is the axis of symmetry. The axis of symmetry is going to be x equals whatever your x equals for the vertex, and that's 3 over 2. So what I'm going to do is I'm going to put a coordinate plane on here. We're going to plot this information, and then we'll get to the inequality part of the quadratic inequality. Okay, so I've drawn myself a coordinate plane over here, and I'm going to go ahead and plot the pieces of information that we've already found using the vertex. So the vertex is at 3/2, negative 1/4. So 3/2 is the same as 1 1/2, and then down 1/4 of a point. So I'm going to go to the right 1 1/2 and down 1/4, and that's just going to be a little bit right there. Okay, so that's my vertex. This is going to be the very lowest point of my graph since I know that my graph opens up. I also know that my axis of symmetry runs right through that point at x equals 3 over 2. So this is where I'm going to cut my parabola into 2 even pieces. So remember yesterday, you can plug in values of x and then get out what the y answer is to plot a few points. You can also use your calculator. You can go back to the original equation and type that into y equals, or you could even do the vertex form and type that into y equals. Then I'm going to go to the table and find a couple of other values that I could plot on here. So I've already put my equation into y1, and then I've gone to the table so I can get a couple of points. I see 0, 2 is a good point, so I'm going to plot the point 0, 2. And then I'm also going to plot the point 3, 2, which would be a little bit off my graph. But we'll put it right there. Okay, I usually want some points on the left-hand side of the vertex and some points on the right side of my vertex. Since I didn't give myself very much room here, then I don't have a lot of points that I can plot. Okay, so we put our points on the graph, and then this is where it's different. Since it says that y is greater than, first thing we're going to do is anytime it's greater than or less than, we're going to do a dashed line to connect our parabola. So I'm going to do a dashed line drawing our parabola going through our points. If it was greater than or equal to or less than or equal to, we would have drawn a solid line for our parabola. Okay, the next thing is we have to figure out if we're going to shade inside our parabola or on the outside of our parabola. And one thing to determine that is I always like to pick a test point somewhere either on the inside or on the outside to see if it's a true statement or not. So I'm going to pick the point 0, 0. I like to pick 0, 0 as long as the graph is not going through 0, 0. So what we're going to do is we're going to plug 0, 0 into our inequality. And I'm going to go back up to the original inequality at the very top. I'm going to plug in 0 for y, and I want to see, is that greater than 0 squared minus 3 times 0 plus 2? If this is a true statement, when I simplify, then I'm going to shade where the 0 is, or on the outside of the parabola. If this is a false statement, then I'm going to shade inside of the parabola, or the opposite side of the point. Okay, so when I simplify, I'm trying to see, is 0 greater than all this stuff on the right-hand side? Well, 0 squared is 0, 3 times 0 is 0, so all of that's going to be gone. I'll be left with a 2 over here. So I want to know, is 0 greater than 2? No, this is a false statement. So since it's false, we are not going to shade where our point 0, 0 came from. We want to shade on the opposite side or inside the parabola. Okay, so you would take your pencil or colored pencil and you're going to shade inside the parabola. So what this means is that any point that is inside the parabola would be a solution, but none of the points that are on the edge of the parabola would be a solution. Okay, so on this next example, I'm actually going to show you using the calculator how you can help you find out what is the graph of a quadratic inequality. So this one says, which is the graph of y is less than negative x squared plus 4x plus 2. So I'm not going to solve this one algebraically like I did last time to get it in vertex form. I'm going to use the calculator. So I'm going to go ahead and type in the calculator the inequality on the right-hand side. So in y equals, I'm going to type negative x squared plus 4x plus 2. Now, because this inequality is less than, then I know that when I'm graphing this inequality, I'm going to use a dotted line. Only when it is less than or equal to or greater than or equal to would it be a solid line. So I know automatically that choices A and B are not correct. So it has to be C or D, a dotted line, because it's just less than. Okay, so I'm going to go ahead and hit graph so I can look at the graph of this parabola. Okay, and we can see that our graph is similar to C and D. So the same thing that I did earlier is you like to pick a point that's either on the inside of the parabola or the outside of the parabola to see if it's a test point, to see if it's actually a solution or not. Okay, so I'm going to pick a point like, let's see here. Let's pick the point 2, 1. I can see the point 2, 1 is inside the parabola. It's easy to identify if it's completely inside or outside. So what I'm going to do over here for my inequality, since I'm picking the point 2, 1, is I'm going to plug 2 in for all of the x's and 1 in for the y. So I'm going to write 1 is less than negative parenthesis 2 squared plus 4 times 2 plus 2. Okay, so I'm trying to see if this is a true statement or a false statement. If this is true, then I will shade where that point came from or the inside of our parabola. If it's a false statement, then I will shade on the outside of the parabola. So I want to see, is 1 less than all this stuff? So 2 squared is 4, times the negative that's outside is a negative 4, plus 4 times 2 is 8, plus 2. So I'm trying to see, is 1 less than negative 4 plus 8 is 4, plus 2 will be 6. So I want to know, is 1 less than 6? Well, 1 is less than 6. This is a true statement. So that means if it's a true statement that you would shade on the inside of the parabola or wherever your point came from. Okay, and we know that it's a dotted line because it's less than and not an equal to. And then it's going to be shaded on the inside, so that's going to be our choice D. Okay, so let me take off the writing here, and I'm going to show you another setting on the calculator. So if I go back to y equals on my calculator, I can go in front of the y, if I go over a couple of times, and you can see it start to blink in front of the y1. You can hit enter a couple of times and it'll give you some options. So if I hit enter once, that gives me a bold line. The second time will give me a shaded above option, or if I hit one more time, that's going to be shaded below or less than. So since this said y is less than, this is the option that I want. And I'm going to hit graph, and we're going to see what happens when I hit graph. Notice it's shaded below, like our answer choice D. Now, the calculator is not going to let you do a dotted line or a solid line. It only does a solid line here. So that may help you determine if you should have shaded inside the parabola or on the outside of the parabola, as long as you know that above is greater than and below is less than. Okay, so example 2, I'm going to do another problem here, graphing by hand. So this is good practice for us finding the vertex form. So I'm going to start with the first 2 numbers or terms, and I want to see, is there a number that I can factor out of those terms? Since there is not a number in front of x squared, then I know I don't have a number to factor out. So I'm going to put x squared minus 4x in parentheses, but I'm going to leave a space, plus 3, and then is less than 0. Okay, so now we need to complete the square. So we're going to take this number in front of x, we're going to divide by 2, and then square it. So this number goes in our blank, so negative 4 divided by 2 is negative 2. Negative 2 squared is going to be a plus 4. Now since I'm adding 4 in this part of the equation, then I need to subtract 4 at the end of my equation. So when I rewrite this as a perfect square, it's always going to be x and then the number before you squared it. So negative 4 divided by 2 was a negative 2 all squared. And then I have 3 minus 4, which will be minus 1, is less than 0. Okay, so now that it's in vertex form, I'm going to go ahead and write down the vertex, the axis of symmetry. I know that this graph opens up. Since it's a positive in front of the parenthesis here, the vertex of this parabola is going to be positive 2, negative 1. Remember, when you take the number out of the parenthesis, it's going to change sign. And then the axis of symmetry for this parabola is going to be x equals 2. Okay, so I'm going to draw my coordinate plane. Okay, so I have my coordinate plane. I'm going to start by labeling the vertex, which is at 2, -1. I know that the axis of symmetry is going to go through that point. So I'm going to draw a dotted line that goes through +2. And then you can use your calculator to help you with a couple of other points, or you can plug in values. If you type the equation into y equals and then go to your table, I'm going to pick a couple of other points that are on the table. So the first one that I see is the point 0,3. And then I have the point 1,0. And then I have our vertex 2, -1. Then the point 3,0, and then the point 4,3. So you can see that your parabola should be pretty symmetrical using those points. Okay, because our inequality is less than and not an equal to, when I draw my parabola, I'm going to do dashed lines going through these points. Okay, if it was greater than or equal to, less than or equal to, it would be a solid line. Okay, now I'm going to pick a test point to determine where I need to shade. So I like to pick a point that's either completely inside or completely outside. It doesn't matter which. 0, 0 again is a nice point because it's nice numbers to plug in. So I'm going to go back to the original problem. I'm going to plug in 0, 0. So I want to see is 0 squared minus 4 times 0 plus 3, is that less than 0? Is this a true statement? If it's a true statement, I'm going to shade where my point 0, 0 is. If it's a false statement, then I will shade on the opposite side or inside the parabola. Okay, so 0 squared and 4 times 0 is just 0. So I'll be left with 3 less than 0. So I want to see, is 3 less than 0? Well, this is a false statement. If it was true, I would shade where the point is on the 0, 0 or outside the parabola. Since this is false, I'm going to shade on the inside of the parabola. So anything inside the parabola and up to the dotted line, my yellow kind of went outside a little bit, but anything up to the dotted line and inside the parabola would be a solution to this inequality. Okay, I'm going to do one more with you using the calculator. So in this example 3, it says solve 0 is less than or equal to -2x squared minus 6x plus 1. So I'm going to go ahead and type this inequality into y equals -2x squared minus 6x plus 1. Okay, it said that it was less than or equal to. So I'm going to go in front of the y1 and I'm going to hit enter until I see a triangle on the underside of that graph. Kind of looks like a bottom right-hand triangle. Okay, so I'm going to hit graph, and then we're going to talk about a few things that are on this graph. Okay, so it's shaded underneath, and since this one says less than or equal to, this would be a solid line whenever I graphed it. I can go to the table to get some values. You can scroll up or down. Notice on here I'm not seeing where my vertex is. Sometimes you can tell where the vertex is. I know that it's between -2 and -1, but not exactly sure where it is based on this table. So one thing you can do using your calculator is you can let it calculate that maximum or minimum value. So you can hit second trace, and I want to know what the maximum is, so I'm going to hit number 4. It's going to ask me 3 questions. It's going to say left bound, right bound, and guess. So for the left, I'm going to take my cursor to the left-hand side of the top of the parabola, just somewhere to the left, and hit enter. Then I'm going to take my cursor to the right-hand side of the parabola somewhere and hit enter. And you should see two triangles that pop up. You're telling your calculator, hey, I think there's a maximum value or the vertex is somewhere in here. Then I'm going to take my cursor and go to the top of the parabola as close as you can, and you're going to hit enter for guess. You're telling the parabola, hey, I think the vertex is somewhere in here. So then it's going to come back and it say, oh, your maximum is at negative 1.5, comma 5.5. And because that's a decimal value, that number didn't show up in our table. We only had whole numbers show up in our table. Okay, so the solution for this quadratic inequality is anything underneath the parabola or on the line would be a solution since it's less than or equal to. Okay, so for your homework from this section, you are only going to do the front side, which says to solve by graphing on this study guide and intervention. Don't worry about the other side. We're only doing the front side where you're graphing.